Hi, my name is Ryan Thompson, and this is CPSC 5210 Final Exam, Question 3. In Question 3A, you're asked to use the master theorem to find the asymptotically tight bounds, given this time complexity. So here, Tn is equal to 5t n divided by 2 plus n squared. A, we have a functional form where this is a t n divided by b plus f of n. So identifying what those variables will represent here, a is equal to 5, b is equal to 2, f of n is equal to n squared. Now, using the master theorem, we have to determine if there exists an n that is polynomially bounded or polynomial differential to f of n. So without having to explicitly evaluate log base 2, 5, we know that that is greater than n squared but less than n cubed. So there does exist an epsilon greater than 0 such that log 2 5 minus n of epsilon is equal to n squared. Thus, this satisfies condition 1 of the master theorem, which leads t of n to be equal to theta n log 2, 5. Now for 3b, we have to prove this bound either using induction or substitution. Here, I've chosen to use substitution. Here, we'll start with big O. So t of n is less than or equal to 5, and we're going to substitute in our theta here. So we have the original form, and now we'll substitute in. So t of n is less than or equal to 5c n divided by 2 log 2 5 plus d plus n squared. Of a lower order term here is based on the suggestion of the reason that I had the lower order term is to help remove these other variables later. So carrying out, we see that the 1/1/2 log 2 5 is really 1/5 times n log 2 5 plus d n squared. And then when you carry the 5 through the equation, this is equal to cn log 2 5 plus 5d plus n squared. So now it's pretty simple to derive a bound for d so that we can take care of the n squared. And so anything less than negative 1/5 n squared for this d term, less than or equal to, gives you cn log less than or equal to log 2 base 5 for any c greater than 0. So this brings us back that t of n is less than or equal to cn log 2 5 given this d term, given this value for the d term. So now the second part of using substitution is to prove the lower bound, big theta, or big omega. So t of n greater than or equal to 5, and it's pretty much the same equation and same process, except for instead of adding the upper bound, I'm subtracting the lower bound. Instead of adding a lower term, I'm subtracting a lower term here. And so we get down to this equation again, and now d is actually the same, which it should be. Same bounds on d, and this makes c of n log 2 5 less than big omega. So now we've proved that t of n is less than or equal to c of n log 2, and t of n is greater than or equal to c of n log 2. And because you've proved it's greater than or equal to both sides, so omega is equal to theta, omega is equal to big O, which is equal to theta n log squared. So you've proved the master theorem by substitution.